This is a quick and dirty video for section 13.1 concerning building chi-square test for the binomial distribution. Here's the problem. Feel free to pause here and read it through. But to build this, we're going to build this over in Excel, and the number of successes I'm going to take right from the data, and I'm going to copy that down. Oops, went too far. There we go. The observed frequency we can bring over. There's the observed frequency. We need to calculate the individual probability. That comes from the binomial distribution. First thing it wants is the number of successes. That's the column right there. Going to hit comma. Number of trials is the number above here. In my setup, F4 to keep it there, comma. Probability of success is this cell. I'm going to hit F4 to keep it there, comma, false. We're going to take advantage of this discrete distribution so that we can have it calculate each piece we need by using false in Excel. And we double click the corner. There's all our individual probabilities. Our expected frequency is going to be the individual probability times the number of times experiments repeated. Again, F4 to keep it there. Double click the down arrow for the expected frequencies. And I say equals parentheses observed minus expected, close parentheses, raised to the second power, divided by expected. There's that value. There's it worked out down the line. Just going to borrow that chi-square real quick and say equals sum of those. And there is our chi-square. But I happen to know from experience that even though this doesn't say 5 and up, that is what the problem is looking for. On the test, it'll be more explicit. So here on the individual probabilities, we need to change this to equals 1 minus sum of everything above it. Everything else corrects itself. So let's see if I remembered all that properly by typing in 534.354. And the answer says, yay, good job. Critical chi-square. Well, we need a few things. We need the number of events that were categorized. That's K. That is the list here of observed frequencies. So we count that. The degrees of freedom is that minus 1. And we need alpha, which we already have. So the chi-square critical is going to be equals chi-square dot inverse dot right tail probability of alpha, comma, degrees of freedom, close parentheses, enter, 15.0863. And we check that, yay! And I will leave it to you to decide on the conclusion from there.